In a previous lesson, we talked about how we can determine whether or not a graph has oblique asymptotes. Now we have two main types of rational graphs with oblique asymptotes, and they would look like this. The first one here has two stationary points and is undefined for this range of values. If this point, which is a maximum, has a y-coordinate A, and this point here, which is a minimum, has y-coordinate B, then this rational graph is not defined for values of y ranging between A and B. In other words, we can say that there are no points on the curve for which y ranges between A and B. Let us look at an example from a past paper. A curve C has equation y is equal to 2x squared plus x minus 1 all over x minus 1. Find the equations of the asymptotes of C. Okay, so let's try to answer the first part of the question. Alright, so on the first part of the question, they want us to find the asymptotes of C. Now, I think you can see already that we should be having oblique asymptotes, simply because the degree of the numerator is 1 greater than the degree of the denominator. So let's start with the vertical asymptote. For the vertical asymptote, we simply set the denominator to 0. So therefore, the equation of the vertical asymptote is x is equal to 1. So that's the vertical asymptote right there. And then for the oblique asymptote, what we need to do is divide x minus 1 into 2x squared plus x minus 1. So I'm going to divide x into 2x squared and we get 2x here, and multiply 2x by x minus 1, so we get 2x squared minus 2x. Then I'll subtract, so x minus 2x gives us 3x. Then I bring down minus 1, and now I divide again x into 3x here, and I get plus 3, and 3 times x minus 1 is 3x minus 3, and we will have a remainder here of 2. But what we're concerned with is the quotient, so therefore the oblique asymptote is y is equal to 2x plus 3. That's the oblique asymptote here. Let's go on to the next part of the question. They say, show that there is no point on C for which y ranges between 1 and 9. Okay, so I think just by reading this, you can have the picture that this is the type of rational graph with oblique asymptotes where we have two turning points, just as I have shown you before. Okay, so I have to take the equation and I'm gonna paste it here. So I'm going to write the equation down. So y is equal to 2x squared plus x minus 1. And that's all over x minus 1. And from here, we'll multiply both sides by x minus 1. So we cancel out the x minus 1s, and what we are left with is on the left side y of x minus 1. And that's all equal to 2x squared plus x minus 1. So simplifying, that's xy minus y is equal to 2x squared plus x minus 1. So I'm going to take everything to one side, and if I do so, then I will be having 2x squared, and that's going to be plus x minus xy minus 1 plus y equal to 0. And finally, if I am going to factor out x there, I'll be having 2x squared plus 1 minus y of x plus minus 1 plus y. I can write that as y minus 1, and that's all equal to 0. So we now have a quadratic form of an equation where we can treat y to be like a constant. Okay, so we now want to prove, according to what they say, show that there is no point on C for which y ranges between 1 and 9. Okay, so this equation that we have obtained here does have real roots. And in order for us to find the points where there are no roots on the curve, b squared minus 4ac is going to be less than 0. That is, if there are no points on C to satisfy the equation. Okay, so let's work on that. Right, so b squared minus 4ac, that's 1 minus y squared minus 4 of 2 of y minus 1, and it's going to be less than 0. Okay, so let's simplify. That's 1 minus 2y plus y squared minus 8 of y minus 1 is less than 0. So that's 1 minus 2y plus y squared minus 8y plus 8 is less than 0. That's y squared minus 10y, and 1 plus 8, that's 9, so plus 9 is less than 0. And we can actually factorize where we have y here and y here, and we have 9 and 1 and minus and minus. So we have it like this, and we have two critical points. Our critical points occur when y is equal to 1 and y is equal to 9. Okay, by equating this to 0. Right, so to find the set of values that satisfy this inequality, I'll make a little sketch. So here, this is y, and it's a U-shaped quadratic where we have greater than 0 above and less than 0 below. And these 2 points, this point here is 1 and this point here is 9. Okay, so for less than 0, that's negative. The set of values satisfying the inequality is therefore set of values of y that are between 1 and 9. And that answers the part where they say show that there is no point on C for which y ranges between 1 and 9. And that's what we have obtained here. So we can say, hence shown. So this question here doesn't require that you make a sketch of the curve. But just for you to know, the graph would look like this. And I think you can notice that we have two turning points here, one of which is this point here with y coordinate 1 and this point here with y coordinate of 9. So what they wanted us to prove in this question was that for the range 1 to 9, there are no points on this graph, or in other words, the graph is undefined for this particular range.